All right, so section 331 is about looking at problems in different ways. And so there are certain problems that you go, okay, there's clearly a best way to do this problem. And then there's other problems where, depending on the person, there might be different ways to approach. So first, we're going to look at the one that's labeled 3107. And we're going to say, is there sort of a best method for solving? And a lot of times when you see parentheses, you jump straight to distributive property. So on this one, I would say I would distribute the first set of parentheses to everything inside the second set of parentheses. We also mentioned that FOIL, first, outside, inside, last, was a way that some people remembered. Basically, the 6x has to get multiplied by both of the parts inside the second set of parentheses. So 6x times 2x is 12x squared. And 6x times 5 would be 30x. Then you've got to do the second number in the parentheses, the minus 11 times 2x, which would be minus 22x, and the minus 11 times 5, which would be minus 55. After that, you just want to look and see if there is any simplifying, and we can simplify the plus 30 with the minus 22, both with the x variable, 12x squared plus 8x minus 55. The second one also, I would be drawn to just using the distributive property. Notice these are both expressions, so we're simplifying. There isn't a lot of different options that you have. So because you've got one thing on the outside bumped up against a set of parentheses, you automatically think distributive property, negative 30x to the fourth, and the second multiplying is a negative times a negative, which would become plus 6x squared y, because I can't combine the x's and the y's. However, an equation like the one below, 4 times, in parentheses, x plus 3 equals 20, there's at least 2 different ways. So way number 1 is what we were just doing, the distributive property. And so if we wanted to use the distributive property, we would say 4 times x plus 3. I'm going to distribute the 4 and get 4x plus 12. It looks like a pretty standard two-step equation. Subtract 12 from both sides and divide by 4. And you're like, okay, great. X equals 2. Move on. Well, there are some other options. You could also do an option called undoing, where instead of distributing that 4, you might actually say, oh, that 4 is being multiplied by something. So the inverse of multiplying the 4 would be dividing by the 4. And I could divide both sides by 4 as a first step. This often keeps our numbers smaller. So some people really like this method. And then we would subtract 3 from both sides and still get x equals 2. A final option, which is a little tricky to sort of wrap your brain around sometimes, is called the look inside method. If you look inside the parentheses and you say 4 times what number would give me 20, and you say, oh, well, the what number in the parentheses must be 5, right? 4 times 5 has to give us 20. If that's the case, then we know x plus 3 has to equal 5, and then we could subtract 2. This method is particularly useful when we're working with exponents. So you don't see people use the look inside method a lot other than exponents, but it would work here as well. All right. Now, this whole second page is considered optional by the program. I'm going to go through and do it just so you can sort of see it, hear my thinking. But this is a little bit more of an extension. David wants to solve for x in the equation 4 times x plus 3 equals 20. He said, I can rewrite this equation by distributing the 4 on the left. After distributing, what should his new equation be? Solve this equation using David's method if you didn't already use it on the front. And we did. On the front, this was our very first option where we distributed the 4 and then solved the two-step equation. Solve by undoing. Juan says, I see the whole thing a different way. Here is how he explains his approach to solving 4 times x plus 3 equals 20, which he calls undoing. Instead of distributing first, I want to eliminate the 4 from the left side by undoing the multiplication. That was our second method that we used. What can Juan do to both sides of his equation to remove the 4? We divided both sides by 4. Multiplication and division are inverse operations. That was our second option. And last, 3-1-11, solving by looking inside. Kenya said, I solved David's equation in a much quicker way. She solved the equation 4 times x plus 3 equals 20 with an approach that she calls looking inside. Here's how she described her thinking. I think about everything inside the parentheses as a group. After all, the parentheses group all that stuff together. I think the contents of the parentheses must be 5 because, and we just said 4 times 5 is the only way to get 20, so the contents of the parentheses would have to be worth 5. This was our third option. In your hard copy of the notes, that page is all filled in. The 3 methods. Match the names of approaches on the left with the examples on the right. We've got rewriting. That's the one that we used, the distributive property, the official title being rewriting. Looking inside and undoing. If 5 to the 8x equals 5 to the 24th, then 8x must equal 24. So we want to say, is that rewriting, is that looking inside, or is that undoing? I did mention on the first page that looking inside often works well for exponents, and this is a perfect example. I don't actually have to do any of these exponents to say, well, 5 to the blank equals 5 to the blank. Those blanks have to be equivalent for the expressions to be equivalent. So the 8x must equal the 24. Subtracting is the opposite of adding. So for the equation 3 times x minus 7 plus 4 equals 23, I can start by subtracting 4 from both sides. So this person on B is using undoing. They are undoing the addition by using subtraction. And the last one, this problem might be easier if I turned 4 times x minus 3 equals 31 into 8x minus 12 equals 31. They've distributed the 4 by rewriting the equation. So mostly at the bottom, it says solving by rewriting. I'm going to go through and do the 3 problems that are there. They are all done out on your paper, but a lot of times looking at a problem that's already done is very overwhelming. So if you need to fast forward or skip through, especially to the second and third. The first one's not so bad, but the second one has an exponent, which is really unique. And the third one has a fraction raised to an exponent that's really unique. So I wouldn't tune out just yet. In the first one on the right-hand side, you've got to do the distributive property or FOIL, depending on how you're looking at it. The 5x squared plus 43 equals, and I'm going to distribute the x times both things in the second set of parentheses, and then I'm going to distribute the minus 1 to both things in the second set of parentheses. And I'm going to notice that if I subtract 5x squared from both sides, then that's gone, and I've got 43 equals. And I would simplify the minus 6x with the minus 5x. Oh, sorry, with the, let's see, minus, let's see what I've got, 5x squared minus 6x. That should be a plus 6x. Fix that one. The x at the front times the 6 at the back is plus 6x. So 43 equals x minus 6. And then I would simply add 6 to both sides to get 49 equals x. And that's it. That's the distributive property on the right, a binomial times a binomial, or FOIL, in order to get the answer. If you want to check your answer, you simply plug 49 into the x on the left, plug 49 into both of the x's on the right to see if the left side equals the right side. And that is all done on your hard copy as well. Here's the biggest problem that people have, and I've mentioned it in a previous set of notes. People think that they can just jump on x plus 3 times x plus 3, and you can't. You cannot just start squaring things. You actually want to write out x plus 3 times x plus 3 and do that same distributive property. So x times x is x squared plus 3x plus 3x plus 9. You have to make sure that you are doing all 4 of those operations in order to not miss any of the terms. So I would have x squared plus 6x, no exponent, plus 9 equals x squared. And the minus 3 times 1 would be minus 3. The minus 3 times minus x would be plus 3x. I can start simplifying. I would subtract x squared from both sides. So I'm actually just going to cross them out because minus x squared would cancel. And then I would have 3x minus 3. I would want to get all of the x terms on the same side. So I would subtract both sides by 3x. And then I would subtract 9 on both sides to get the left side as the only side with a variable, and divide by 3. X equals -4. It's not a terrible problem, but if you don't nail that first step, it doesn't matter if all of your algebra after that is correct. So here is the biggest issue that people have with the problems with the exponents. Last, I have to distribute that -2 by everything that is inside the parentheses. Now, all of that's on the left side of the equal sign. So I'm going to have 4x squared minus 2x plus 10. The right side of the equal sign, you do have to do a bunch of simplifying. I would suggest, first of all, this 8/4, that's just going to make some huge numbers. The first thing I would do is make that 2x over y squared so that I'm simplifying the 8 and the 4. And then I have to do that exponent. I have to actually do 2xy times 2xy, which is 4x squared over y squared. And I'm also multiplying it. Now this is 1 over y to the -2nd. When you go to multiply those two in the bottom, y to the 2nd times y to the -2nd, you're going to get y to the 0, which is worth 1. So this is going to be 4x squared over 1, or just 4x squared. This piece, which I haven't been using, is 4x squared minus 2x plus 10 equals 4x squared. If I subtract 4x squared from both sides, I get -2x plus 10 equals 0. Please do not stop there. This is still something that you can solve. You can subtract 10 from both sides, and you can divide by -2. For some reason, I get a lot of people that stop once they get equals 0. And I'm like, well, you didn't get x yet. Keep going. The two problems that are here remaining, B and C, you can also look at the check on the hard copy of the notes. If you substitute negative back 4 in for all of the x's, the left side should equal the right side. And if you substitute on C 5 back in for all of the x's, the left side equals the right side. So today what we have sort of expanded upon is the idea that there's multiple ways to solve problems. Rewriting, which is also the distributive property. Looking inside where you say, oh, this chunk inside the parentheses or this chunk in the exponent has to equal a certain number. And last is undoing, which is where you, instead of distributing, you immediately say, oh, instead of multiplying by that 4, I'm going to divide both sides by 4 and use inverse operations right away. So hopefully everybody has a question or two for me during class, and I will see you then. Bye.